So the first thing we wanted to just show you, we've been putting together a directory of all patent data sets that we know about to try to help people find data when they're looking for data. And this is an open directory, so we're happy to list anybody who wants to be listed. Sam, do you want to show them the spreadsheet?
Absolutely. And I'm also posting a link in the chat.
Excellent.
So here is our datasets page. If you visit the iCube site, there's a little tab for public datasets, and we're cataloging metadata about the datasets in this Google Sheet. You can just use this form to share datasets that you've used in your work, or datasets that are important to your work, even if you're not using them now. And particularly datasets you're publishing. And then if, as you're doing this, you realize you would like a permanent identifier for your dataset, let us know. You can use DataCite directly, or we can get you a DOI for it.
Mm-hmm. And all this data here is one of the conditions for the data that it be clean license. So in other words, something that was to involve some CompuStat data or other data which is essentially not officially postable would not be includable in this data set, in this sheet.
We encourage you to submit data sets based on how important it is to you, and indicate the license. We're going to flag those that are freely reusable and fully accessible, and have a highlights section.
Josh, we're having kind of an ongoing discussion about to what extent we should be prescriptive. So I think for the moment, we're just including everything, but noting whether it's really available or not. At some point, I think we might make the decision that because we encourage open access, that if you don't want to play that game, somehow you won't be part of us. But at least so far, we've decided to err on the side of being inclusive with information rather than screening stuff out.
Right. I mean, I guess the issue I was thinking of is saying, a number of us may have data sets we want to share, but also be cognizant that the sharing of them might be a little bit fuzzy under the copyright law. So in a way, either sort of being able to say, look, Josh has got some data on finance patents he's glad to share, or else somehow not putting a huge advertisement in it saying Josh is eager to infringe copyright law and invite litigation from Standard & Poor's for incorporating some CompuStat data that should be open access but isn't.
The terms of use column presumably can encompass some of that, but I understand what Josh is saying, because I have shared data over the years on the basis that it's quite old, and really of no interest to any commercial use. But on the other hand, you don't want to advertise it.
Right.
I have traditionally shared it saying you should have access to CompuStat at your institution to use this, thing that I've created. There is also the possibility of, not including a data link and making people go to the holder of the data to get it. I mean, that's the safest. The safest solution.
But the issue. I'm sorry if this is kidnapping the conversation, Adam.
Yeah, it is a bit.
Okay.
I think maybe this is a good topic for the session we're going to have next year, where we really talk about in more detail how we want to go about encouraging open data. So I think for now, the bottom line is we will list anything anyone wants to list. You should put any restrictions you want to note there. That don't list with us if you feel that it's potentially exposing you. And then I think we can have more discussion about this at our next session.
Okay. I have one minor comment for Sam. on the page, the first page, not the second page, not the spreadsheet page, but the other page, it isn't entirely clear when you look at that page that picture of the data set list is incomplete. You have to read carefully to see that. I would suggest a sort of visible link, or ad or something that really makes people realize that that's an incomplete. I kept wanting to scroll it, when
Yes,
I was
very
looking
good.
at it. Yeah.
We can actually, we can just embed.
Understood.
Thanks, Robin.
Yeah, no, that's a good. I had the same problem the first time I went to it too. So that's a good point. Okay, and this is actually a good lead in to the only other thing I wanted to say, and then we'll let our history folks get going, which is we're going to have a session early in 2021 specifically on the topic of making data sets, how to share data sets, and what are the different options of how you do that, and what role should I3 play in that? How should we think about sort of standards for documentation and interoperability and so forth. So I think that would be, the kind of issue that Josh is raising would be exactly the kind of thing that we would discuss then. So you'll get a notice about that. You're like me, and the I3 messages get sent to your junk folder automatically by Outlook. You might want to check your junk folder periodically, or feel free to email me personally if you haven't heard about it and say, is this really happening? I haven't heard about it. And if you have, and I'm not putting you on the spot, Josh, but if you have specific thoughts on this subject or a subtopic you'd particularly like to see addressed, shoot me an email or shoot Sam an email. And, we have not yet put together a quote unquote program for that meeting. So we'd be happy to have thoughts to say something and be on, be part of it, or just a topic they'd like to see addressed in it. Because I think it is an important topic for us as a group. Okay, anything else by way of preliminaries from anyone? Sam, Laura? Okay, then I think we'll just go in the order you originally listed in the program. Mike, take it away.
Okay, sounds good.
And you have 20 minutes, and I will harass you. I'll let you know when you've got 2, and then I'll harass you at 20.
Okay, my understanding is Dan has a little less than 20, so I'm going to go just a hair, probably 23 to 25-ish, if I can abuse everyone's time.
Has the gentleman from wherever's
yes, the gentleman has assented.
Yielded his time.
I have yielded my time in advance.
Okay, so you get 40 minutes between you, starting with Mike.
Okay, sounds good. I guess one small plug for historical data before I even get started is there are often fewer restrictions on use. So one thing that's very interesting about historical data. Let me just say thank you to everyone for being here, coming to the last but hopefully not the least of these I3 sessions for the fall. What I'll be talking to you about today is joint work with Enrico Berkes, Christian Fons Rosen, Joe Price, Sharda, and Nick Zebarth. I know several of whom are on this call, so hopefully maybe you guys can check the chat for me. Before I get into talking specifically about what we do, I actually want to take a few minutes and try and motivate, I think, above and beyond data access issues, why I think historical patents are so interesting and so important, and something that those of us in the innovation and patent data community should really think about. Hopefully motivate not just my talk, but Dan and Tania's as well. I think probably most people on this call have used patent data in some form or another, and that's probably involved going to PatStat or going to the MBR patent data, downloading the data and using it. That data begins in 1976. And you might ask, why does it begin in 1976? We, of course, have had patent data dating to far before that. Patents were explicitly mentioned in the US Constitution. The first patent law is in 1790. There's a big patent office fire in 1836 that destroyed a lot of records, but at least from 1836 all the way up to the present, we have, I would say, a remarkably consistent history of patents. Why does this data begin in 1976? And the reason very simply is because that's when the USPTO began keeping patent data in a digital format, which of course is very convenient for researchers to use. So, it begins in 1976, but of course our patent data doesn't begin in 1976. And you can think of many contexts where it might be useful to have patent data that extends before that date or maybe spans that cutoff date. I think there's at least 3 reasons this is so. First of all, there's a lot of studies. I've conducted some, my co-authors have conducted some, others have as well, in which we really want to understand the long-term effects of innovation policy or innovation on something. And for studies like this, it's really useful to have several decades of data, again, often going back before 1976. Second thing is that when we actually look at history, we find that it's often I would say, a much better setting to test theories about innovation than often we have today. We just have a much bigger playground to look for variation or find natural experiments or things like that. And the third reason I think historical data is so great has to do with linking patent data to other sources. So if you've seen a lot of the other talks in the i3 series this year, a lot of the things we'd like to do is be able to figure out more about the invention that is listed in a patent, or figure out more about who the inventor of a given patent is, than we can learn just from looking at the patent document itself. Thinking back, for instance, to our talks on the gender of patentees. And to do that, often we need to link a patent document to some other source. And today, that's often difficult for confidentiality reasons. But one of the great things about history is once everybody is dead, often you care a lot less about confidentiality. So for instance, several of us have worked on linking patent data to the US Census. I can't do that today. I can't go to the 2010 census and see where everybody lives, what their name is, all of that. But I can do it for the 1940 census. The US Census is sealed, classified for 72 years. So for the historical data, we're able to link patents to sources like this that we couldn't do today. So with all of that as sort of a long-winded preamble, I think our 2 big goals for this project are pretty easy to understand. And I think these are probably also goals that Dan and Tania would agree with as sort of overarching objectives for those of us working on historical patent data. The first thing we really want to do is construct historical patent data that's as good as modern patents. And what do I mean by as good as? I think at least 3 things. So first of all, we'd like to have a record of patents that is as complete as modern patents today. So we have basically information on the universe of patents. We want to make sure that information is accurate, as accurate as we get in these digitized patent records today. And we'd like to get as much information about each patent as we have today. So the entirety of the text, in addition to just sort of patent metadata. And the second thing that's a big goal for us, keeping in mind that one of the benefits of historical data is that we can link it to other sources, we'd like to develop better ways to learn about the identities of inventors. This entails 2 things. First, for better strategies to actually link patents to other sources. And then what I'll be introducing today, which I'm particularly excited about, is a new source to which we link, or actually several sources. I'll talk about that as we go forward. So what specifically do we do here? The first thing we do is build what I think is a better historical patent data set. And when I say we build this really has been all Enrico Berkes' work here. Enrico's been working for the last several years on something called the Comprehensive Universe of US Patents, or Cusp. So version 1.0 and 2.0 already exist, have been used by several researchers. In fact, I have a paper that compares several historical patent data sets. And I think even looking at previous versions of the Cusp, it's already sort of the gold standard in terms of historical patents, in terms of completeness, accuracy, and what information we have about each patent. What Enrico's been working on now is building version 3.0, which is going to actually improve on some of the weaknesses of version 1 and version 2, specifically as it relates to accuracy of the OCR, of the optical character recognition, and getting data that's useful for us to be able to link. After that, I'm gonna talk to you a little bit about some new methods to link patent data to other records, in particular focusing on how we geotag patents. And then what do we actually link patents to? I'll show you some results where we try and link patents to US decennial censuses, but the real innovation here is linking to a genealogical data source, FamilySearch, which contains far more information than just decennial census records. It actually contains all sorts of different records, which will first of all help us to link each patent. It will allow us to validate the links we have. And maybe most interestingly, it's going to help us to disambiguate across patent records. So this is the big outline for the talk today. Before I get into some more of the nitty-gritty details, let me first say a little bit about why it's not so trivial to build a great historical patent data set. So we do have image files for all of these patents issued, at least from 1836 to the present. This is what they look like. This is actually for the first rotating wheel can opener to William Lyman of Meriden, Connecticut in 1870. And for those of you that only look at modern patents, one of the first things you may notice is that image quality is not so great on a page like this, right? There's just a lot of mess, a lot of smudges, black marks throughout the page, which makes OCR difficult. And I should say this is far from the worst patent that one can find after just a few minutes of Googling. There's been a couple of previous efforts to try and OCR the universe of patent records, including these historical patents, by both the USPTO and by Google Patents. So this is the Google patent entry for William Lyman's can opener patent. I don't know how well you can read this, but up here, this is supposed to be the name of William Lyman. This is supposed to say Meriden, Connecticut. Even if you go down into the body of the patent, into the text, it's really a lot of gibberish. This again is supposed to be William Lyman. So if you want to try and parse out key inventor information, especially if you want to use the text and think about sentence structure, things like that, what we have here is really, frankly, kind of a mess. So if we really want to do with historical patents the kinds of things we do with modern patents, we need a better OCR, frankly. We need a better way to extract information from these historical patents. One of the things we've noticed through previous versions of Cusp and previous versions of other historical patent data sets, one of the real challenges is maintaining the integrity of the structure of each page when you're doing this OCR. One of the challenges with historical patents is that the format changes over time in terms of column structure and things like that. And especially as we want to be able to recreate the entire text of the patent and do more than just pull out metadata, it becomes important to keep these sorts of things in mind. So for instance, if you scan a patent and it's very tilted, something like this can make it difficult to figure out what's the structure of the columns, which might make it difficult to figure out, where are our claims down here? How are the claims written? Can we find an inventor's signature? In many cases, if we don't have a vertical line down the middle, it's actually even hard for many OCR software like Tesseract to even detect what's the difference between one column and another. So these are all sorts of issues that we've had to think about when trying to develop better historical patent data. Okay, so without going too far into the weeds, let me just mention a little bit about what Enrico's been doing for this version 3.0 of the Cusp. First of all, when we start out, we want to start out with these high quality images as we can. And that means using TIFF files from the PTO rather than PDFs. Next step is to really get the coordinates for every element on a page. And Enrico's put a lot of time into this for various reasons, found that OmniPage works better than Tesseract or other sources. Once we have that, we can start thinking about really rebuilding the page of the patent in a format that we can actually use. So determining the page structure then is important. And here, one of the things that's taken a lot of thought and it's still sort of ongoing work is thinking about computational efficiency, right? If it takes like a second per page to determine the page structure, we've got something like 6 or 7 million patents pre-1976, each with several pages, that adds up very quickly. So once we have this, we can rebuild each page, and then we can parse out the relevant patent information. So there's some key patent information that you think most data sets would have, the issue date, maybe the filing date, the patent number, maybe inventor names, assignee names, and locations. But in prior versions of the Cusp, Enrico's actually tried to pull out in-text citations. We can look at things like the number of the claims. And then again, because we have the entire patent text, we can really think about getting anything that we could get from modern patents. And in fact, because we've rebuilt the entirety of these pages, if there's something that later researchers find out would be useful to have from each patent, we can go back and easily pull this from these documents rather than having to re-OCR everything. So we are here right now in terms of the progress. Enrico's here in terms of progress of version 3.0 of the Cusp. So this is ongoing work. What I'll be showing you in the rest of this talk are results using a pilot of the improved Cusp data. Okay. I also want to highlight a couple things that Enrico's been doing and we've been doing with this Cusp data when we're building it to try and help with linkage moving forward. So one thing that I think is important to highlight is whenever possible, we're trying to collect redundant information from each patent. So if you look at a patent like this, you'll notice that we have the inventor's name up here in the header, appears here in the first line of the patent text, as well as down here in the signature attestation. Typically, a lot of times when you're building and parsing these data, you just collect the name from one place. And if you look closely here, you'll see up here at the top, we have the name listed as A.S. Thompson. Down here, we have the name as Amasa S. Thompson. So if you're actually trying to link to something like a census record, you want as complete a name as possible. If we just get this from one place, we're, as likely as not to not have the full name, and hence to have some difficulties linking, either leading to too many false positives or not being able to link as well, link at all. And it's actually a bit frustrating. It's not just that up here in the header, we often get initials, and down here we get the full name. There's cases where down here in the signature, we get initials, and up here we get the full name. So we really need both. And then we can use either or both in doing the matching to ensure we do the best job matching as we can. The next thing I want to talk about is determining the location of a patent or an inventor on a patent. And one thing that I think maybe we don't think about enough is there's really nothing disciplining how an inventor records their location on a patent. It's supposed to be the town and state of residence, but what you actually list as the town is maybe not so trivial. So let me give you an example. You find many inventors from Massachusetts who list their city of residence as Charlestown, even in years after Charlestown is annexed and becomes part of Boston. So this here, for a lot of you probably are up in the Cambridge area, very familiar with, is a map of Boston. Charlestown's right there. It's hard to say whether an inventor is actually going to list their town as Boston or Charlestown. If we're trying to link between two records, say link between the patent records and the census records, if the patentee lists their town as Charlestown, the records in the census list the town as Boston, and we're matching on the string of the town, we're going to fail to get a match here. So what we do instead is geolocate each patent, actually get coordinates, Latin long for each patent. So we will match town names in both the patent records and actually in the records we're trying to match to the Geographical Names Information System, GNIS, to get the coordinates of each town. Any town not in the GNIS, we can query Google Maps to get coordinates. And then when we do this linking between records, what we can do is look for people who are within a given radius of the patentee. So we've used 5 kilometers as a cutoff so far. That's of course tunable. 5 kilometers has worked well for our pilot sample, but we can think about other ways to do this. And only consider candidate matches those that are within a given radius. So this solves the problem of how does someone actually list as a string their location of residence? Do they list a neighborhood or a ward rather than the city that would appear on their postal address? If you're on the outskirts of town, do you list, but outside the municipal borders, do you list yourself as being in town or not? We can overcome those problems. So you can see here for Charlestown, we get Boston, or if you're right across the line in Somerville or Cambridge, we would pick that up when we're doing the linking as well. Okay, so how do we actually do this linking? The first thing we try and do with this data is link from the Cusp patent records to the decennial censuses. Again, something that prior researchers have done. So what we're going to do here is for each inventor who's listed in the Cusp, we're going to identify all individuals in the census within this 5 kilometer cutoff who are at least 15 years old at the time the patent issues. And then what we'll do is identify individuals with similar last names. So this has 2 passes. Actually, we'll first find names that match exactly. Then we'll find names with a Levenstein distance of 1. So what I want to emphasize is this is actually a quite conservative way to try and look for a match. Many other studies of matching between census records or patent records to census records, we use a much more liberal cutoffs for looking for a match. Next, we'll look for common first name abbreviations, and then we'll actually match the first names. So if the last name matches exactly, we'll consider a first name to match if it's the Levenstein distance is 1 or less. If the last name doesn't match exactly, we will require the first names to match exactly. So again, this is quite conservative in terms of how we're doing the matching. If we don't have the full first name, we'll use the first initials instead. And then we can use the inventor's middle name or middle initial to eliminate false positive matches. So I just want to stress that every step in this matching criteria is designed to be conservative. Our goal here is really to think, Now that we have higher quality patent images and we have what we think is a better way to match on location, let's see how good we can do with that while still being quite conservative on actually what we consider to be a match. So let me give you some matching statistics or diagnostics here. Again, as a pilot, we've matched the 41,000 patentees in the US who obtain a patent between 1855 and 1865. And we're going to link these or try and link these to the 1860 decennial census. What do we find? Well, we find that we match about 58% of these patentees, about 24,000 patents. By matching, what I mean is 58% of the patent records match to, using the matching criteria, matching algorithm on the previous slide, match to at least one record in the 1860 census. To put this number in perspective, so some of the work I've done with Sharda and Nick also matches patent records to decennial censuses. We get a match rate of about 10%, again, using a slightly more liberal matching criteria. So this is quite an improvement. I do want to caution, it's always difficult comparing matching statistics like this across studies because if I flip back, whoops, the algorithm can vary so much. So, how you're actually doing the linking, we actually don't link to the 1860 census. We link to 1870 to 1940, so we have a different sample as well. So it's tough to compare these things. I think this greater number, though, is really being driven by the higher quality OCR, as well as how we link location. I do want to point out, it's possible to get sort of arbitrarily high match rates if you liberalize the criteria on which you match. So for instance, if you don't block on location at all, if you're just looking for something that has a similar name, or if you don't use the first name or middle name data, it's possible to get quite high match rates. So what I want to stress is that we have a very high match rate here while being very conservative in our matching process. About 1/3 of these matches match to more than one record in the census. Average number of matches per matched patent is about 3.5. This is in line with what Sharda and Nick and I find in our study. Okay. I also want to point out, we get fairly different match rates over time. So remember, we're matching to the 1860 census. We're matching patents in the year that they issue. So typically these list inventor locations at the time the patent files, which could be the previous year, or maybe 2 years before in the 1860s. So what you see is we have very high match rates in the years close to the census that we're matching to. So that's exactly what we should predict. We get much lower match rates in 1855 and 1865 when we're further from the census that we're matching to. So again, I don't think this is not really surprising if we think about what we're doing. People move over time. The record we're trying to match to is in one given year. But it's a bit of a problem when we're trying to figure out about these inventors, who they are, because one of the great things about patent data is we have this information for every year, but what we link to is only a given point in time. So what would be great is if we had a way or had another source we could link to that was closer to these inventors in 1855 or 1856 and these inventors over here in 1865. So this is exactly where the FamilySearch data comes in. So for those of you who aren't familiar, FamilySearch is a nonprofit family history organization with 12.6 million users. In fact, typically how FamilySearch works, because it's a genealogical organization, people will go online and manually try and find records for their deceased relatives. So we have a lot of manual matching going on here for how we actually identify records and link across records. We have 1.2 billion profiles for deceased individuals. In fact, I think the goal of FamilySearch is quite modestly, hope I'm not overstepping or overstating anything here, but it seems to be to learn everything there is to know about everybody who's ever lived. And they're off to a pretty good start here, right? 1.2 billion records. And you look at how much information we know about these people, it's quite impressive. So for each of these 1.2 billion profiles, what they've done at FamilySearch is build, it's called a census tree, although it doesn't just contain census data, a census tree where every record that's affiliated with that profile will be linked up in the FamilySearch data. So we've got data coming from censuses, birth, marriage, death certificates, taxation, voter rolls, church histories, court documents, land records, wills, military records, family histories, memoirs, published stories, and more. So there's a lot of stuff here in this FamilySearch data, which is, economic historians really exciting. So why is this so useful for us? Let me walk through an example. This is one of the patentees that we failed to find a match for. We're linking from the Cusp patents to the 1860 census. This is E.B. Bigelow from Boston, Massachusetts in 1855. In fact, E.B. Bigelow, you can see right here, is one of these guys who we only have the first initial up here in the header. His name is Erastus B. Bigelow from the patent text or the signature. So we failed to match Erastus trying to link from the patents to the census. So the question is, can we do better using the FamilySearch data? So what we'll do is go into FamilySearch. Hopefully you can read this a little bit, and we can plug in Erastus Bigelow, and I know he's residing in Boston, Massachusetts in 1855. So we could of course relax the year range a little bit, but we're going to look for records specifically in 1855. And it turns out right here, if you do that, we find a match in the FamilySearch to an E.B. Bigelow living in Boston, Massachusetts in 1855. This is actually coming from the Massachusetts State Census in 1855. Now, I think I know a little bit about historical data, at least relative to maybe the modal person studying innovation. I had no idea Massachusetts conducted a state census in 1855. And I suspect cases like this are pretty common, where there's data that even people fairly versed in this space didn't know exist, or even if we knew it existed, didn't know it was digitized and in a format that could be used for matching. So this is pretty cool. If you click on Mr. Bigelow here, we actually learn even more. So this is everything we know about E.B. Bigelow from that 1855 census record. So we know gender, age, estimated birth year, birthplace. We know his family members here. And if I go over and I click here, this takes me to the profile for Erastus Bigelow. And I can see, if I go to sources, I can see all the other records that are affiliated with the same person. And here I can see basically where he was residing at different points in time. There's a couple things I want to point out about this just to emphasize why I think this is so cool. First of all,
Mike,
yeah.
Even with your couple extra minutes, you're close to the end here. So
no problem. I'm very close to finish.
Okay.
Thanks, Adam. We don't see an 1860 census record here for Mr. Bigelow. So this means that the FamilySearch folks couldn't find Mr. Bigelow in the 1860 census. We couldn't find him either. This probably means this is an individual who just wasn't enumerated in 1860. So what that means is if we did find a match between Mr. Bigelow in the patent record and the 1860 census, that's probably an erroneous match. It's probably a false positive. Even if we match to 1850 instead, we see that he's living in Clinton, Massachusetts, not Boston. Right, so if we found a match in Boston in 1850, that would also probably be an erroneous match. But you can see, I hope, why I think this is so exciting for disambiguation, right? Because I know where a given individual is living at different points in time. If I find a patentee to E.B. Bigelow living in Clinton in 1850, I can be pretty confident this is the same as the E.B. Bigelow living in Boston in 1855. So we think that's pretty cool. Just real quick, I'll walk through some statistics here. With a very small sample of these unmatched inventors in 1855, we manually looked for these people in FamilySearch. As we scale up, of course, this is something we can automate. About half of those people that failed to match to the 1860 census, we actually were able to find matches for in FamilySearch. So if these rates hold for the entire sample, that means between matching to the 1860 census and the FamilySearch data, we can match almost 80% of these inventors, which is a fantastic rate, especially given how conservative we've been in that first stage of matching. I should also mention about 26% of these we were able to find 1860 census records for in FamilySearch. It's not quite a fair comparison because we're manually doing the search here, so we can sort of clean up some of these OCR issues. So we're pretty confident as we improve the OCR and the Cusp, this number will come down. Okay, this is my last slide. So hopefully I've already conveyed why I think it's really exciting that we can actually match to FamilySearch like this. First of all, it lets us match to sources above and beyond things like the Decennial census, all in one place. Using these census trees, it becomes really easy to disambiguate across inventors. And I think it's also important to point out, by linking in these patents into FamilySearch, we're also improving the genealogical data because now we're improving the breadth of their coverage. Now people can look up, patents held by their ancestors and things like that as well. So apologize for going over. Dan, I hope I didn't step on your toes too much here. I'll stop here. Thanks a lot. Look forward to your questions.
Okay, thanks, Mike. And we'll collect the questions for the end. We'll move on to Dan. And you said you want about 10 minutes, Dan?
Yeah, I think I'll need about 10 minutes. I'm trying to hold a few minutes for Tania as well. But thanks, Mike, for getting us started. I think that's really exciting work. I'm going to connect with it conceptually in a couple ways. Credit has to go to that whole team, as well as, of course, Joe. Many folks in this room may not actually know Joe, but he's a wonderful resource collaborator and running just a fantastic program out of BYU to try to enrich the FamilySearch data. So there is a lot there too. I saw questions in chat. Let me transition us to talking about some other historical data sources. Now, what I wanted to do here is basically try to be a little bit of a cheerleader or motivational speaker, or just give people a nudge to think about using maybe by our standards non-traditional, non-electronic data, because there's a lot of information sitting out in printed records that can really be useful in research. So there we go. So just to give you some examples of papers that have done this before, you have Petra's work with using World's Fair exhibition catalogs, or Tom Nicholas's work using National Research Council's directories of corporate R&D labs. You have other work that's linking to individuals. I have some work that actually uses records from the National Archives on secrecy orders, on OSRD supported patenting in World War II. And so to think about partitioning the set of the information that you can get from these other sources, there's a lot out there, I think, to enrich research that you can link to technology areas, to specific assignees, to inventors, to funders, or to USPTO actions. There's interesting variation, and the data actually exist. It just takes work to find it and get it. And I'll provide you some hints in this talk too. This is partly meant for this audience, partly meant just for being posted on the web. So some examples of data sources that haven't yet been used in research. I'm not checking the chat, by the way. I'll look at that later. You have individual historical patent examination files. In principle, this is like PAIR before there was PAIR. I'll give you an example in just a moment. You can find patent applications going pretty far back. This is a link to the actual National Archives catalog listing. You can see interference proceedings. You can find information on trademarks and trademark cancellation. That in of itself, I could imagine a paper springing out of something like that when a trademark gets canceled. So for a more hands-on flavor, take a look right now at this screenshot. This is correspondence from an examiner to Robert Goddard for rocket apparatus, a patent application that was filed in October of 1913. And this is fantastic. I mean, it's super interesting to actually, see the process itself. But what does this show you right off the bat? It shows you the examining division. It shows you what I believe this is basically the sequence of letters. So this is the second in a series. You have the correspondence date. You have the what I interpret to be the patent attorney. And then you also have, this is just to get you jazzed up, you have the actual letter itself. Let me see if I can read this out to you. This application has been examined. Claims 2 and 3 are rejected. The applicant's claims do not define over these patents. Claim 6 is rejected, etc. And so interestingly, among other things, we have this issue in patent data, which is that front page citations, which remember, identify prior art that was considered in the course of examination as being relevant to prosecution. That record only begins in 1947, because it's only in 1947 that the USPTO required patents to be published with prior art references. That's not to say that those linkages didn't exist before. They of course did. They're used in examination, and this is how you can find them. And so here right now you see the grounds on which this 2 claims from this patent were rejected. So what's involved, the structure of these slides, I won't say I'll go into all the detail in this talk, but of these slides, really boils down to finding and obtaining data. Typically, these are primary source documents, and then actually extracting their contents into a data set. And some of the places where you can find information, if you're on the hunt, there's the National Archives, which is where a lot of my attention is focused. The U.S. National Archives. You have corporate archives around the country. I've worked out of the AT&T archives. I've worked with the Hagley Museum, which has a lot of the DuPont records. You also have university libraries. You have microfilm and offsite collections at those places too. But actually the most accessible ones are digitized books and also trade journals, like you have at HathiTrust or Google Books. I've used them in various ways as well. I can tell you stories perhaps afterwards or offline. Just a quick word about NARA though, because I think this is one of the richest resources here. It is the official record keeper of the government, of the US government, and has a vast collection that dates back to the country's founding. And there is in its collection an entire record group for just the USPTO. And so if you wanted to somehow leverage USPTO policy experiments or any kind of internal administrative data, it generally will exist. Now, there are, of course, records of other agencies that intersect with patent policy, which my work has made use of. And so there really is a lot there. So I'm going to include in these slides some hands-on tips for how to work with and out of NARA. I'm not going to talk through it now because it's in the weeds. This is meant to be a resource for people to reference later. Because there is a bit of tacit knowledge, there's a bit of a learning curve to working the system. And of course, I'm happy to be in touch by email and give tips and suggestions too. But I wanted to make this available, and so just know that this will be online. The other thing worth just circling back to is that again, there are data at corporate archives, especially at some of the big companies of the 20th century, where records can be pretty well preserved. And in many cases, there's actually interest in collaborating and sharing with researchers. I've worked, like I mentioned, out of the AT&T corporate archives for my telephone operators paper, and it was a great experience, and I got a lot of great information from it, both on, this isn't patent data, to be clear, but this is to illustrate the point. Plenty of documents that had data printed on them that I then used in the research. And so any of the major research performing, R&D performing firms of the 20th century, if they still exist, will likely have corporate archives. If they're now defunct, they might have donated their collections to a nearby university archives, and so you can still find them there. And the advice for them would be similar. Those are in the slides I skipped over. I have a few comments I can make here, but again, this is more for posting on how to actually extract the data, because it's one thing to find it, another thing to turn it into a usable data set. That the one thing I would say, on that point is just it does require some research budget, and I think some TLC to make sure that things are internally consistent and you're comfortable with the quality of the data. But that's process. I'll just wrap up in the spirit of keeping things brief by first of all thanking Adam and the other organizers of the initiative for pulling this together, and in the spirit of what we do here, encouraging people to continue sharing data, and just feel free to reach out to me anytime with questions on accessing historical and archival data sources. So thanks very much. I will pass the baton over to Tania.
Great, thanks, Dan.
Let me share my slides. First of all, I just want to say huge thanks to Adam, Laura, and Sam for organizing this series. This was extremely useful for me to learn what people are doing, and and participate in this group. So thank you so much for doing this for the community. And I hope you can continue in the future and participate in the future. And thanks for all of you who are here today. I'm going to share with you about 2 data efforts, which one of them builds on Enrico's wonderful methodology to extract information from patent text, and quite similar methodology to what Mike was describing, tried to link inventors to censuses and across censuses. So this has been great introduction, Mike, and endorse everything that you said. But specifically, I also want to convince you that the patent data allows quite unique opportunity to study drivers and consequences of technological entrepreneurship over the long run. And this is where I kind of come in. My research is an intersection of entrepreneurship, innovation, adoption of new technologies, and how they affect economic outcomes. Why do we care about entrepreneurship, specifically technological entrepreneurship? Is because it's a lot of wonderful people, and in this group as well, show that this is important for innovation and for growth. And one of the biggest challenges in studying both drivers and impact of technological entrepreneurship is that we don't have any data really for the US prior to the 1980s when modern data becomes available. And this is where kind of these projects comes in. I started this all data collection for more than 4 years ago, so it's been ongoing effort, and this is I don't know, 3.0 or 4.0 iteration of this. But I do strongly believe, after working with the patent data, that it provides the best measure of technological entrepreneurship for the US specifically, that a lot of people can use in their work. So what are other challenges with current data on technological entrepreneurship? If you try to understand drivers and impact of tech entrepreneurship, you will notice that the current activity is very highly geographically concentrated. So if you want to understand any geographical drivers or local kind of spillover effects, it's very hard to identify things empirically. And another big struggle that I've had and other people had in this area is that it turns out it's really hard to measure quality of entrepreneurship, not just quantity. And I think patent data allows to solve this by using patent citations. So specifically, I'm going to talk about 2 data sets. I'll focus more on the first one, which essentially is a longitudinal county level measure of entrepreneurship over the past couple of hundred of years. And this comes from USPTO patent data, where identify entrepreneurs by focusing on patents filed by independent inventors. I'll talk about in a few seconds why. And this is really cool opportunity for us to understand what were the important things that affected entrepreneurship in the short and the long run. And as Mike was saying, we can use a lot of natural experiments and wonderful variation in the data to measure consequences of entrepreneurship. I'm gonna talk a little bit about how I construct this data, but it's built on Enrico's really wonderful methodology, so I don't have any kind of contributions there. And I'll show you application of how the data can be used, which from my paper Crisis Innovation with Asaf Bernstein and Filippo Mezzanotte, that you can find on my webpage if you're interested in more detail. And the second data set, so in that paper, essentially, we try to understand how Great Depression affected subsequent innovative activity. And we identify the effects by comparing areas that were harder hit by the crisis compared to less hit by the crisis. The second data set is a longitudinal inventor level data of inventors that patent from 1905 to 1945. I'll talk more about that data. Why would you want to link inventors through time and space by first matching them to censuses, which is extremely hard and very expensive, I can tell you, exercise. I guess should have said that huge thanks also goes to Columbia Business School, who sponsored years of this data collection exercise. It's because the modern methods of linking inventors across patents don't work. We don't have, most patents were single inventor patents, 95% of them before like 1960s. So you cannot use co-inventor networks to link people across. Patent technology classifications and technologies have been changing rapidly. You cannot use that as well. And as I show you, most patents were produced by these independent inventors who invented outside of traditional firms. So you can't use co-authors to link people across. And I've tried many different things, and I'm happy to share other things I've tried to link people across time and space. And this is the only thing that was produced good results, I think. Let me tell you first about the county level measure of technological entrepreneurship. Again, this builds on Enrico's wonderful work, and I'm not going to go into details. You can find details in Enrico's description of the methodology, as well as what other things I do to the data to clean it up in online appendix A on my website under crisis innovation paper. But essentially, to get a bunch of information from the patent text, such as inventors and assignee names, filing date, and location of the inventors, or more accurately, a team of very talented computer science RAs re-OCR'd all patent text to extract that information. This data also gives us patent citations similar to Enrico, patent citations from front page start from 1947, but also some in text starting from 1910. Technological classification is helpful here as well. It exists for all patents. So it's really comprehensive data that allows to measure innovative activity, not just of entrepreneurs, but all kinds of producers of innovation, as I'll talk in a few slides. And Adam, can you tell me how much time I have so I can? You
still have a good 10, 15 minutes.
10, 15. Okay, cool.
Yeah.
Great. So then we're doing great. Now, how do you build the longitudinal, the county level data on technological entrepreneurship through time? Well, you get inventor, city, state, and country information. You enter this into Google Maps, which gives very accurate current county of an inventor's location. And then, depending on application, you want to convert the current counties in the counties of the period that you are interested in studying. And this is a problem more generally that we talked in this group a few weeks back. The issue is in the US and other places is that counties tend to change through time. So it's really important to keep track of that. So, for example, for application to the Great Depression, we manually map all current counties and counties that existed as of the beginning of the Great Depression, 1930, and then create panel data using that information. It's county changing borders and names is not such a big deal for this particular application to the Great Depression, because we find that 87% of 1,900 counties did not change any county borders or codes now. But before that, it's much more complicated because there is a lot of changes. So if you guys have any suggestions on how to deal with these mapping of counties through time and creating consistent data set of geography through time, I would really love to hear any of the suggestions that you might have. All right, so let me tell you about the quality of the data a little bit, so you understand, I guess, you can judge how good it is or not. So after we extracted and standardized data, we had a few undergraduate RAs who manually checked 100 randomly drawn patents from each decade and compared it to actual PDFs of the patents to see whether information is correct or not. We find that practically all patents in our data have correct country information. Among US patents, 95% have the correct county information, again, which is useful for the county level data over time. And for comparison, his past data, which was one of the pioneering data sets publicly available that provided innovative activity through with geographic information on it, has about 80% of patents, of US patents, populate county information. We also find that about 94% have correct, exactly correct inventor spelled name, and 92% correctly spelled assignees. Assignees are not, names are not super important for this project, but it's helpful to see that there is a very high quality data that comes out. And in part, as most of you know, this is because the OCRing technology improved dramatically over the past few years. And I expect it's going to continue in the future. So I commend Mike and co-authors on doing even more sophisticated parsing out of the information. And comparing, so Enrico was extremely helpful in this effort, and he shared his data a couple of years ago. So looking at county level data in Enrico and our data, we find that out of those that disagree in a random sample, Enrico's correct about 25%, and we are correct about 67% of the time. So there is a little bit of improvement over Enrico's data, which, by the way, I just want to emphasize that his data was already really great, because we agree on 90% of county level information. All right, so how do we measure technological entrepreneurship? That's $1 million question that I spent quite a lot of time to understand by reading work of wonderful economic historians who studied entrepreneurship in the 19th and beginning of the 20th century. And the most consistent message comes out that one of the best measures of technological entrepreneurship is these patents that are not assigned to anybody. Or you hear they're called independent patents. Who are these independent guys? Interestingly, very similar to technology entrepreneurs today, they have two economic features that make them kind of good proxy for measures of technological entrepreneurship. First, in terms of financing, like entrepreneurs today, they either self-financed their inventions or raised money from local angel investors to produce their innovation. And secondly, just like entrepreneurs today, in terms of commercialization, they either started their own companies or sold the patents to larger firms to commercialization. So these two features make them a good proxy for technological entrepreneurship. Now, how important these folks were, if you look at entire span in the data through now, you have 20% of all USPTO patents done by these guys. And if you limit to prior the availability of NBR data, you have them produce, 44% of all patents. Now, how does it compare to firm innovation? In bullet point number 4 here, we see that while firms are quite important today, they were less important in the past. Independent inventors being the biggest group historically. Now, what are US firm patents? In bullet point number 4 here, I'm going to just continue here a little bit out of order. We know from work of Naomi Lamoureux and Tom Nicholas and other wonderful historians that inventors who worked for firms tended to assign their patents to firms because they were contractually obliged. So firms that assign to firms, patents that are assigned to firms essentially should be a measure of innovation produced inside more traditional firms. Now, there are two intermediary measures that can go either way, either in more traditional firm innovation, or maybe in technological entrepreneurship measure, which are bullets to number 2 and 3 here. Patents that are assigned to individuals, there is not a lot of economic history work on this, what those folks are, but from we know, these individuals, assignees, tended to be either investors in the innovation or businessmen who wanted to commercialize this. Third group here is patents that are assigned to firms that have similar name to the inventor. Think about Thomas Edison Electric Company, which commercialized his light bulb invention. So, first of what I want to say is that for our crisis innovation paper and for summary statistics that to follow, I'm going to focus on this first group. But practically or theoretically, second and third group can also be considered technological innovation. And we're also using regexes and regexes. We also identify other patenting by US government, universities, and non-US patents. So essentially, we classify all patents into all of these groups. But again, the focus is on tech entrepreneurship because I think that's kind of the biggest contribution in terms of data to that field. Now, if we plot time series over these statistics over time, as you all know, there is a big increase in non-US patents over time. But if you zoom in onto the US patents specifically, you see that this red group of independent non-assigned patents, which I'm going to use as a main measure of technological entrepreneurship, was the biggest group right before the Great Depression. And there is a big shift into firms over time. Now, we also done some validation of this measure. Well, how do you validate it? If you have any additional suggestions, I'd love to hear. But what I've done is I correlated county level measures of independent innovations with other data that gives us entrepreneurship measures when both are available. For example, I correlated county level share of employment in new firms in the US Census data from 1980s now with my county level shares of independent inventors. And it turns out they're quite correlated. There is almost 50% correlation. Interestingly, they are both also correlated in the time series, as I show here in this figure. I also correlated this county level measure of independent inventions with self-employment that you can get from decennial census data that starts from 1910 through now. Actually, that was the data which I started with, and I realized that it's actually not that great in terms of time series. But cross-sectionally, there is also a 50% correlation with my measure. So now, in terms of applying this data, you can do lots of wonderful things. But one aspect of the data you can explore is time series variation. Here, I plot from a figure from our paper with Asaf and Filippo of count of patents by major technology classes around the Great Depression. You see there is big drop during Great Depression. Interestingly, there is also a decline during the pandemic, which kind of rebound later on. So this is time series variation. In terms of cross-sectional variation, you can do difference analysis, for example, by comparing different counties that are affected by different shocks. Differentiative in our crisis innovation paper, we do run a difference analysis by comparing counties that were harder hit by the crisis, by the Great Depression, compared to less harder hit counties, and look at the time series estimates over time. And we find that during the Great Depression, there was a big drop in patent counts by independent inventors, by these technological entrepreneurs, and look at these just amazing persistence over time. So this is what Mike was saying, that you can look at really long run effects of shocks or natural experiments over time. But interestingly, the other aspect of the patent data, which is the quality of innovation measured by future citations, tells us this is not bad, because we find that high quality innovation did not got negatively affected. It was all worse patents, actually. So innovation was quite resilient to the Great Depression. Now, let me briefly talk to you about the other effort, which is linking inventors across space and time. And this is very similar methodology to what Mike was saying. First, you link inventors to censuses, and then take information from censuses that is time invariant. For example, you take inventors' age or year of birth and birthplace, which are the common two variables that prior efforts, important efforts in this space have done. And then you can use that information to link people across censuses. And in the paper, we apply these to study relocation effects to the crisis. And for a lot of details, you can dive into my 200-page appendix B on my website under crisis innovation. So how do we know? Mike is right. It's really extremely difficult task to do. How do we know that we get good matches? Because we don't have a ground truth sample here to compare to. So I've done a few things. I looked at characteristics of inventors compared to all males in census and said, well, do inventors look like we expect them to be? And one of the most wonderful things that comes out is the answer is no, they look very different. For example, if you look at the distribution of occupations, they are very different. For example, in 1930 male census universe, 13% of people are farmers. If you look at the inventors to census match data, you see that under 3% of them are farmers. So I do this and other things to show that indeed inventors look very, very different from the general population. I'm going to skip some summary statistics because I'm out of time. You can all find all of these in the appendix in the crisis innovation paper. And since I'm out of time, let me just conclude. I think patent data has an immense potential to change and stimulate study of technological entrepreneurship, because I think it's the only data that provides consistent data on technological entrepreneurship over time and space. I show you the application to using county level measure technological entrepreneurship over the past 200 years and applying that to study how Great Depression affected innovation. But you can think about a lot of many different events that we just don't know how they affected innovation. Prior to the NBR patent data, technological entrepreneurship is the major group producing patents. So it's another reason why we want to use this data to study innovation produced by these independent inventors. And this really cool data allows us to overcome a lot of challenges with current data. It allows us to study driver supervision before census data becomes available in 1980s, and allows us to study long run effects. It allows us to use natural experiments. And if you look in the data geographically, technological entrepreneurs was much less concentrated than currently. So you have a lot of useful variation in the data for identification and measurement of things. And finally, I think it's really unique data in terms of allowing to measure quality of technological entrepreneurship, because it allows with future citations and really understand the impact of shocks on innovation, not just on the quantity, but also on the distribution of quality across different, worse versus better quality innovations. Thank you so much, and I look forward to your comments and questions.
Thanks, Tania. That was really great. And thanks to all three speakers. I think this is just a fabulous area that we're all sort of learning about. So we've got about 20 minutes now for general comments. I mean, there's been a lot of discussion in the chat, and I don't know that we need to sort of recover the things that were covered there, but if anybody has anything they want to ask about, now's your time to chime in.
Yeah, I have comments, Adam.
Go, Bronwyn.
Yeah. So you saw it in one of Tania's charts, something which I was going to raise with Mike, which is just from the point of view of, you know, how good is the match? The number of foreign inventors who presumably you're not going to match to the US Census seems like you need to remove them. In order, you'd have higher rates if you got rid of them. Tania's chart shows exactly what I expected, which is that in 1865 you get the Paris Convention, and suddenly the foreigners are treated the same, and patenting grows by foreigners. There's a kind of a jump in her graph, which I suspect is due, you know, partly to that. Obviously, there's also the market becomes more appealing in the U.S. over the 19th century. So there's going to be a smooth trend anyway. I mean, it's going to be worthwhile for foreigners to come in. And then I had one minor question, but I think I'll just explore it on the NBR website, which is just, I looked at the OCR of the 1940 census, obviously looking for members of my family, and found them, but it's amazing to me that you could get anything out of those census records. And you know, that's much it, and so I've been done is been OCR'd, and the NBR has it on the website. You know, it's interesting for me to learn that. The final comment I have for people is it occurred to me when looking at the Depression era, you know, studies that Tania's doing, that it might be useful for people to go back and look at the pioneer in this area, which is Jacob Schmuckler, who published an entire book in Innovation and Economic Growth based on the historical analysis of patent statistics, and see whether, you know, given the new and better data, we're, you know, what we're learning that might contradict some of his conclusions or confirm them. I don't know if the book is still available. I have a copy, but and I assume it's in the library somewhere. But it's well worth taking a look at. Okay, that's all I wanted to say at the moment.
Yeah, if I can real quick respond. I mean, I think you're absolutely right about the OCR quality for the actually for the censuses. I'm actually, Joe maybe would know better than me whether those are OCR or whether those are hand transcribed. But I mean, it is worth pointing out that just because we can't match from the patent to the census doesn't mean it's an issue with the patent data. It can also be an issue with the census. Right. And I think this is one of the great things about FamilySearch is some of those have been, you know, looked at another time, manually cleaned up. So actually might be better than the transcriptions or OCRs of the censuses we can find on, say, the NBR servers. For our match rates, I'll have to check with Enrico on this, but I know for at least our earlier paper, that's the share of patents with basically for which we could identify a valid U.S. state. So the denominator there is U.S.
Mm-hmm. Okay.
But you can, of course, you know, play around with how you calculate that.
If I may add to this, there was a discussion in chat, which Bitsy started, that the complete count census data on NBI servers are coming from FamilySearch. So it is clean data. And I agree with Mike and other people that the quality of the match will vary dramatically depending on how clean the patent data is and or how clean the census data is. I think, and for example, another way to extract inventor information is from the reports from USPTO that provide inventor names. This is where Mike, I think, and co-author started. But the issue there, the OCR maybe is not so great, and also there you can only have one inventor name versus, I think Mike was pointing out that in patent text you have 3 mentions of the inventor, which allows to increase the precision of the accuracy of inventor name dramatically once you have 3 mentions. And I'm grateful, Brahmi, for suggesting to look at this book. I'll email you to ask for reference if you don't mind.
Yeah, no problem.
Other comments or questions? Well, if no one else does, I have a question, I think mainly for Tania, but others might have thoughts about it as well. In the linking of these early patents, the individual patents to other places, is there any way to get any insight? We know that today, most patents go nowhere. So these individual patents are potential entrepreneurship occurrences. They're not actual entrepreneurship occurrences because we don't know that the inventor, just from the patent, we don't know the inventor ever did anything with the patent. Do we have any way to get any purchase on that, to find other indicators of, you know, an actual business starting or something like that?
Very good question. So first way, empirical way to address this was for me to correlate the county level measure of entrepreneurship with other measures of entrepreneurship, local entrepreneurship that we have. And empirically, they are highly correlated. So at least at the minimum, you can think of these measures of local inventiveness and dynamism by early stage inventors. Now, but this raises a much deeper question and discussion as to you know, what are these independent inventors represent, and whether we can think of them as entrepreneurs or not. I think you're right. You know, we know from economic history that most of them will not start their own company, right? They will invent, sell a patent, and move on. Invent, sell a patent, and move on. But I think conceptually you can think of this as early stage innovation that is produced outside of boundaries of traditional firms. Once you start thinking that way, then it's very similar in economic features and content to technological entrepreneurs of today, if you will. Yeah. In terms of matching these to other data sets to see if they start or don't start a firm, one thing I've done, which is available very easily from the patents themselves, is you can identify patents that are assigned to company that is named after inventor, right? So that's kind of a measure of somebody doing invention and very likely starting a firm. It's correlated, as you would expect, with the other measure of unassigned patents, of independent patents, but it's very small fraction of innovation, if you will. I looked into case studies, and you know, as you expect, some inventors start firms, some don't, but I don't have any comprehensive, I don't know of any comprehensive data that would allow to precisely pinpoint all of them as entrepreneurs or not. What I've done though is after I matched inventors to complete count censuses, you can see whether which provide you with whether people were self-employed or employed employed by somebody else. You see that the independent inventors are much more likely to be entrepreneurs, but it's not 100%.
Right. Just to follow up, when you looked at the correlation with other measures of entrepreneurship, you know, of course, if the patenting rate was precisely 10% of the entrepreneurship in every county, that would be a perfect correlation, but it would still be telling you that 90% of the patents aren't going anywhere. So have you looked at not just the correlation, but how the magnitudes compare? Is the average rate of patenting, you know, 1/10 or 1/2 or twice or 3 times the average reported entrepreneurship rate?
it depends on. Oh, let me show you on the slide. So here is one very imperfect measure of local dynamism entrepreneurship, which is a share of employment in young firms, which is a blue line, and the scale is on the left for that measure, right? So you see, as most of you know, there's been decline in the economic activity in young firms and decrease in new firm creation, which starts at 15% at the beginning of sample and goes down to less than 10% recently. If you look at the share of patents at the same time that are independent, it's a little bit bigger. If you see on the right scale and red line, right? It's starting from somewhere around 25%, but also goes down quite a bit.
I don't think that's what you want.
No,
I think you want to look at independent patents per total employees.
Because the denominators on each side are also changing. So I think I mean, it's an interesting graph for other questions, but for the question of sort of what is the rate of patenting compared to the rate of entrepreneurship, I think it's not the right comparison.
Yeah.
Awesome. Thank you, guys. We can definitely do that.
It essentially tells you about the invention composition, the right-hand side,
That's right.
which is interesting, but not the same thing.
Right.
So if I can jump in here.
Mike, let me jump in for a second.
Go ahead, Nick.
I was just going to say on this point regarding kind of more historical resources that you could sort of look into business formation, stuff like that. So, you know, there's the census of manufacturers in the 19th century. And there they're asked to list like the name of the business or the owner. So I think like Rick Hornbeck is working on digitizing those full census of manufacturers, like all of it. I mean, there's this random sample now that ATAC and Bateman put together, but I don't think they have the names on there. So you couldn't really make that work. So that's one thing. And the other thing that actually Sharad and I have worked on a little bit is working with these Dun and Bradstreet records, which are these sort of, it's like a credit reporting agency that goes way back, and they list all kinds of different businesses, not just manufacturing, but you know, all kinds of different stuff. And so there again, for the cases where either you know that the patent was assigned to some business, you can find that business in Dun & Bradstreet, or if it's the business is named after the person, you could find them there as well. So I think there are some other sources out there that you could look into for the 19th century, but it's definitely some more work to dig.
Yeah, I mean, in a sense, it's a whole nother project, which is analogous to what you guys have been doing with the main census, but in principle, there's something there.
Yeah, I think one other source. Go ahead, Nick. I'm sorry.
Yeah, I mean, I think the issue with like the census of manufacturers is that you're just going to get probably a vanishingly small number of patents that match to a manufacturing establishment. Mm-hmm. Whereas you might have a better chance if you look at, say, Dun & Bradstreet, which has lots of different kinds of businesses, not just, manufacturing establishments.
Right.
By the 1930s, though, there are other economic censuses too, right? There's the census of retailers, and I know there's. Yeah,
there's the census of distribution, and there is the retail census, but again, those are a mess.
One other source, if I could, sort of building on what Dan talked about, one thing that's sitting there in the National Archives right now related to patents are these assignment records, so comparable to the USPTO's patent assignment database. So they have listed post-issuance assignments. So I think we should remember, when we look at the assignee on a patent, that's who the patent is sold to at the time the patent issues. They can, of course, be sold after that. And the PTO has records of those. They're a nightmare. They're in these huge library volumes, handwritten. So I'm not sure I'd advocate doing that for this project, but they're super cool. They contain not just who the patent transfers to, but also the terms of the sale. So there's a lot of data in there. I know Naomi Lamoureux's worked with this a little bit for small samples, but for somebody with a lot of money and time, that'd be, I think, a fantastic thing for someone in this group.
Mike, do we know, I mean, we know today that many patents that are assigned, that the PTO is not told about the assignment. There's no requirement that that be done. Do we know anything about historically how prevalent it was to actually tell the PTO when a patent was assigned?
My understanding, maybe Bitsy or Tanya or someone can correct me if this is wrong, I think the legal requirement has stayed basically consistent. So you'll want to report it to the PTO if there's a chance you want to, assert the patent or something, but there's probably a lot of assignment and even more importantly, there's probably a ton of licensing that just never gets
right. Okay, other topics or questions or comments? This has been really interesting. Okay, well, I think we can adjourn. We are going to have a session for those of you who maybe joined late. We're going to have a session early in the new year on just the nuts and bolts of sharing data sets and issues both for you individually and for us as a group to think about, and as we try to encourage that more. And then we are kind of open as to what we want to continue doing. I think, at least my view is, these Zoom workshops have been incredibly interesting and useful, and there's no reason why we can't keep doing them. If people have particular thoughts, either for just a topic for one session, or more generally a way of structuring these to that would be interesting, or maybe just different that we might try, shoot me an email. We'll be talking about it, and stay tuned for further developments.